First of all, I want to start off to thank Sparks to have opportunities like this for us young researchers to kind of get our feet wet and to be able to talk to an audience like this. So here today, I'm going to talk about my work as an undergrad. This is my honors thesis, and it's looking at canine cognition through the Hamilton search and set-breaking task. So to start off with our objectives here, we wanted to establish the validity of the Hamilton search, a spatial foraging task for the study of canine spatial learning. And so this task is thought to assess memory, inhibition control, cognitive flexibility, as well as spatial search strategies. And so on top of that, we also wanted to look at the differences among different breeds of domestic dogs. And then again, the Hamilton search is a new task to dogs, but it has been used with a number of other species, one of which is infant pigtail macaque monkeys. A little bit of background. So the Hamilton search falls into the category of spatial cognition, and this is evolutionarily beneficial to canines in regards to both scavenging and hunting, as well as the jobs that we train them to do today. And spatial cognition is a non-social cognitive task, which has been studied in canines, but as Jim kind of alluded to, there are still many gaps in this field. Onto our methods. So I looked at 28 privately owned domestic dogs. They ranged from a year and a half to 14 years old, all being cognitively mature. We had 17 males and 11 females. I looked at 4 different breeds: Bijons, Labs, Goldens, and of course, from the University of Washington, I had to include Dubs, our Alaskan Malamute mascot here. And so in our outgroup comparison, we also had 88 infant pigtail macaque monkeys. Our testing apparatus, as you can see here, is something that I built, and I made it so it was portable, so I went to a familiar location for each of the dogs that I tested. The main aspect of this is that there's 4 buckets. Inside the buckets, there's a metal mesh trap, which enclosed a food reward in order to control for smell. So this was a visual task. Then they were securely attached to a wooden board, and there's PVC dividers with fabric that allowed them to look at one single bucket at a time. So there was no cheating. And then the other elements were the flooring was consistent for all the locations I took it to, as well as having a metal X-pen to be my fence. To start this off, we had the familiarization phase, and this conducted in 4 phases. The first was to establish that there's food in the buckets. The third was then to establish that there's food in all of the buckets, but it is only obtainable in one. And this was by far the hardest stage for the dogs to learn, that yes, there's a cookie there, but we need to find the one that you can get. And then finally, in that 4th phase, it mirrored the Hamilton search protocol. So this established that there's going to be one food reward, and it could be any of those 4 buckets. The Hamilton search, the important element of this is that the food reward was randomly placed. And then trials were conducted in 5 sessions of 16 trials, and this took a matter of 3 to 5 days. And during the trials, I recorded the search pattern. Next, they moved on to the set-breaking protocol. And so this is where the rules of the games changed, but everything else remained the same. So we're trying to see how long it took the dogs to queue in. So now, the reward was based on a fixed location, and this was calculated based on the trials on the Hamilton search. So we found what bucket they went to least frequently. So we then continued trials until they queued into this, and our criterion was that they had to go directly to the correct location 5 times in a row. Because in this setup, the food reward is highly predictable. It's going to be the same place. You can tell from one trial to the next where the reward is. That wasn't the case in the Hamilton search. And so here you're going to see an example. This was Virgil completing the Hamilton search task. So as you see here, he goes to 4, to 3, to 2, and he gets the reward. Trial is completed. And then he comes on back, and each dog would then go behind a blind. For him, it was a kennel behind a mat, so he couldn't see the setup of the next trial. And so then I go set up the trial, and I'm using a high-value treat. So it varied from dog to dog, but something that they were extremely motivated to work for. And as a result, all of the dogs, I became their new best friend. They loved participating in this research. And so here he comes out again. We get lined up. He's on a release cue. And he goes back to 4. And in this trial, happened to be that's where the reward was. But this is one of the key things about the dogs. You're going to see the systematic nature that they approach this task. So again, he goes back in his little waiting area. I reset up the task. And you'll notice too, not only do I just place the food reward, but I go through and I touch every single container, again to control for smell. We want this to be a visual task that they cannot cheat. And he comes on out and is released again. And what a shocker, he goes 4. Not in 4, we go to 3, to 2, and we get the reward in 1. And then the trial is complete, and those continued. I want to show another example here of a dog named Data. His parents happen to be professors, research professors, hence the name Data. But look at the speed that he goes through this. It's an extremely rapid approach, which is one of the strategies that we're going to talk about later. And then we're going to show another example of Jake, who this is what happens when they don't start on that outer container. He goes to 3, to 4. He looks in that visible 5. He rechecks 3, 2, and then 1 gets the reward. So that's an example of what would happen if they make an error on that task. So ideally, you're going to be not rechecking the boxes. You should recall, I already went to this 3rd one, and therefore not go to it again. And on to our results. So one of the important variables that we looked at was the number examined. So that is the average number of boxes examined in each trial. And the higher number examined each trial would indicate memory errors. And if we are comparing to perfect memory, you would expect an average of 2.5 boxes examined per trial, given that the placement is random. So as you can see from our graph and the chart here, dogs were statistically above perfect memory, except for Dubs, which again, this was an N of 1. I only had 1 breed to compare to, but Cat helped to report it, given that is our mascot. But another important factor is that there was no effective session. So dogs in the first session performed the same level as they did in the 5th. And that would indicate that they're not further learning this task as the trials increased. And then another factor that we found was breed differences. So we found that Bijans created or had more errors than the retrievers and the macaques. Another one of the variables that we looked at was the probability of selecting an outer box, and that's 1 or 4. And this indicates the systematic nature of their search. And we found that all of the animals, the dogs and the macaques, preferred to start in an outer box, and this was above chance. We did see a breed effect, mainly driven by Dubs, as he was almost 100% starting in an outer container. But another important factor is that we found an effective session. So unlike the number examined, dogs from session 1 to session 5 increased in their probability to search in an outer container. So they became more systematic with time. Their search strategy became stereotyped and ritualized. We also found a sex effect. So we found that males were more likely to start in an outer container than females, and they showed no preference. And as you can see, there are some breed differences here, and that was mainly driven by the differences in the Bijans. Another factor that we looked at was latency. So this was from when they were released until the food reward was found. We found an effective session. Dogs got faster with time. We found an effect of breed, with the Bijans being significantly slower than the Malamute and the retrievers. Granted, this could be due to size. We have 20 pounds and under compared to definitely larger than 20 pounds. And we also found an effective sex where the females were faster than the males. Now onto the set breaking. So this again was when we changed the rules of the game. Everything else remained the same, but now the location of the food reward could be predicted. And it was based on their least favorite container, which would be the opposite of their start search. And so as you can see here from the first graph, there was no breed differences. We didn't see the same effect that we did in Hamilton search. Bichons and retrievers both had an extremely long range. And so here I have to point out a couple of dogs. We have Zest, and Zest was a record breaker. She completed set breaking in 7 trials. The minimum was 5. She was very quick to adapt. But then we have Charlie, and this I can laugh about being my own dog, who took 183 times to cue into that the game has changed and you can find. So he went 1, 2, 3, 4, 170 plus times before he figured it out. But this was not just a Bichon or lab thing. As we have data with about 10 trials, also very quick. And we have Tessa here in the triple digits. But as you can see from the best fit line, we found a strong age effect. So these younger dogs were more easily able to adjust their strategy compared to the older dogs, which could be an indication that they lost some of their cognitive flexibility. So kind of wrapping things up here, what do we know? In Hamilton search, we know that all animals, on average, examined the same number of boxes throughout the trials. There wasn't learning in that sense. But as the session increased, the probability increased that the dogs would start on the outer container. They became very stereotyped, as well as the latency decreased as the number of sessions increased. So they became faster with time. They were more efficient, they could have been more motivated, things of that nature. And for set breaking, we found that there was no breed difference in the total number of trials to the criterion, and that the total number of trials varied greatly. There was no perfect number that a dog would hit this many repetitions and go, oh, I got it. Oh, it's always going to be here. They had a hard time overriding that associative learning. But we also found that strong age effect. So what does this all mean? Dogs approach this task with a very systematic approach, which it's an efficient alternative to the use of memory. This was not seen in the monkeys. But when you look at a task like this, you have to look at what are the costs of making such errors. No matter if they looked in 2 boxes or 10 boxes, most of the trials were done in under 10 seconds, and for sure under 30 seconds. Could it have been that the cost to inhibit looking at another box wasn't that great? So what if you look in the box again? It doesn't do a whole lot, they still find the food reward. So are there things that we can do to increase the cost? One of the protocols that's done with the monkeys is something called forced set breaking. So it's the same approach to set breaking, except for they're only allowed to make 1 trial, or 1 search. So they go through, they make a choice, they look at a box, the trial is done. I didn't do this with the dogs, but that is a way to see, could we get them to cue in faster? Are they going to adjust their strategy when there's a greater cost to making an error? And then also some future directions. Now that we've established dogs can do this task and they do it in this way, how can we ask more interesting questions? Can we further look at breed differences? I only looked at Bichons, Labs, Retrievers, and the token Malamute. Are we going to see the effect of the Malamute by increasing the number, or is that effect going to diminish? And what about other breeds? And then another thing that we could do, how can we get them to override that associative learning? They learn this through a process of trial and error. What about adding an element of social learning? If they watch a dog demonstrator do the same task with a different strategy, will they adapt? And the same could be done for a human. So it kind of adds elements of the pointing research that's been done, but to a different task. And then finally, I'd like to acknowledge everyone that helped me get here. So here we have all the pictures of the dogs that participated in my research, and I couldn't have done it without the owners who are willing to rearrange their schedules, help me, because this took a minimum of probably about 5 days from each of the owners, and in order to get all of this data. And then of course, I have to thank Jim Ha, who has been extremely helpful and motivating for my interest in animal behavior and the further desire to pursue education. And I'd also like to thank Camp Canine Dog Daycare, who allowed and opened up their facility for me to test some of the dogs while they were at daycare. And then I received some support for this research through the Mary Gates Endowment Scholarship at UW. Thank you very much.